Have this handout ready. We're going to talk about how to name some molecules today, and we're going to be using what's called IUPAC nomenclature. And IUPAC nomenclature is also discussed in your text. And the IUPAC is an acronym which stands for the International Union of Pure and Applied Chemistry. That stands for the International Union of Pure and Applied Chemistry. You're not going to see that name. You don't have to define it or whatever. But one of the reasons why I bring it up is that if you think of what it stands for, again, it stands for an international union. This is a group of chemists from around the world that has agreed upon these conventions for naming these chemicals. And what's really kind of cool about that is that chemistry is one of the few languages, or one of the few subjects where we all speak the same language. And it doesn't matter what your country of origin is or your native language. When it comes to organic chemistry, we all speak the same language. And that's not true of many things. About the only other analogy I can give with that would be like math. If it comes to math, we all speak the same language when it comes to math. If we see 3 plus 3, we may not pronounce it 3 plus 3, but if we saw the symbols on there, 3 plus 3, we all know that means we're to take 3 and add it to 3 and wind up with a total of 6. So when it comes to IUPAC nomenclature, it's the same thing. If we see these names of chemicals, regardless of what our native tongue is, when it comes to these chemicals, we all speak the same language and assign chemicals the same name. Now, obviously, if you look through these rules, you see that they're based on which language? Well, they're based on English, okay? So those that have some native language other than English basically need to adopt these. And when I've had students from that have other native languages and they come in, pronounce some of them, they might sound a little different, but we all spell them the same thing. So where we might talk about methyl, when I've had some of my foreign students, I might hear something like methyl as a pronunciation for them. But again, they're all spelled the same, and we use the same convention at arriving at those names. So what we're going to look at first is the isomers of C6H14 that you built, and we're going to talk about how to name them using this sheet of rules that we just had. So again, isomers of C6H14. And I'm going to start by picking this first one up right here and having you look at this. And I'm going to try to get 2 or 3 different models up here right now. Does anybody have a model that is different than this one right here? You got one there? Okay. Take a look at these 2 models. Who has one that is different than one of these 2? You got one there? No, you got one. All right, that looks like we got a different one back here. So we're going to start with these 3 examples and look at how we would go about naming these. And we're going to start with the simplest of these. And again, we're going to do it by following through the rules that we have there for the nomenclature. So again, pull out your sheet and we'll start at the very top. And the first thing we're going to do, we're going to look at this one. We'll actually write out its structure. So if I write out the structure, what we're going to see is we have a total of 6 carbon atoms in a row. And so I'm going to write out 1, 2, 3, 4, 5, 6. And so when you write these out, I would always suggest by writing them by putting the carbon backbone first. And then from here we add in the hydrogens. So remember that carbon always makes
4 bonds.
4 bonds. Hydrogen always makes 1 bond. So we start on the end here with the right-hand carbon. This carbon here should have how many hydrogens? 3. Next one would have 2. Next would have 2, 2, 2, and 3 on the end. And of course, once you draw it out, we should verify that we have the correct number of carbons and hydrogens. We already counted the number of carbons. we count hydrogens, we have 3, 5, 7, 9, 11, and 3 more makes 14 hydrogens in the structure. Then when it comes to naming it, says what we're going to do is we're going to identify and name the parent chain, and the parent chain is the longest consecutive chain of carbon atoms in the molecule. So if you're going to do it, what I'd suggest you do is just take your finger and trace along, and if you trace along, I'm going to use my highlighter here. We'll highlight through here. We see that we have how many carbon atoms in a row?
6.
6. Very simple. So 6 in a row in this case. Then what our rules tell us is that we name this parent chain. So a parent chain, an alkane that has 6 carbons is called hexane. Good. Called hexane. And so we'll write out the number or the name for this one, and we'll call this one hexane. So again, this one here is hexane. We go to the next one that we have out here. Let's check out this guy. We look carefully at this one now. What is the longest consecutive chain of carbon atoms in this molecule?
5.
We have 5. And again, the best test is just hold your finger down there, and if we count 1, 2, 3, 4, 5 in a row, that would be the parent chain. Now we can actually arrive at it 2 ways. We get 1, 2, 3, 4, 5, or we go 1, 2, 3, 4, 5. And either way, we find that the longest consecutive chain is 5 carbons. So we have the 5 carbon. This gives us the parent chain. This parent chain would have a name of pentane. That would be pentane. And then we have this branch off of the parent chain. And how many carbon atoms are in this branch?
1.
1. And this is an alkyl group, and with 1 carbon, this would be called a methyl group. So what our rules tell us that we do here now is this. We go on to the next step, and it tells us that we are going to identify and name all of the branches off the parent chain as alkyl groups. We talked about this last class period. An alkyl group is an alkane that has had 1 hydrogen atom removed. The hydrogen atom is removed from the end of the, okay, we did that before. The name of the alkyl group then precedes the name of the parent chain. And so what does it mean if it precedes?
Comes before.
Comes before. So the name of this is going to be methyl pentane. So methyl pentane is the name that we give to this. Well, now let's go ahead and draw this out. If we were to draw it out, we want that parent chain, which again has how many carbons? 5. And then we have a branch off the parent chain, and now where we locate this is going to be important. This is stuck to which carbon atom in that parent chain?
The 4th one.
Well, we're saying the 4th. Okay? But turns out that when we look at these, there's some rules that talks about the position as well. And it says that number 3 is we're going to locate and assign a number to the position of each branch off of the parent chain. If we have a single branch off the parent chain, like we do right here, what we're going to do is we're going to count in the direction that gives us the lowest number. And then we're going to place that number in front of the alkyl group, separating the number and the name with a hyphen. So, if we look at this, we could count from left to right and count with 1, 2, 3, 4, or we can count from right to left and count with 1, 2. And so the number we assign then is number 2. And the reason for that, if we always want to count from left to right, is we just simply turn this around and we can see then that it is in position number 2. And we then place it right on top of here. But now, as far as how we write it, we could write it up above here, we could write it down below, we could write it over here, up above, or we could write it down below. And all of these positions are equivalent to each other because you remember, all we're doing here is simply turning the molecule around. That doesn't change who it is, just like it doesn't change who I am if I turn around. And likewise, we could put it on the top or the bottom, and that doesn't matter as well because all of those positions are just different orientations of the same molecule. So just to be difficult, I'll put it here so it looks like it's on the fourth. Then we're going to add in our hydrogens. If we add the hydrogens in on the top, this one here would have how many?
3.
3. One on the right-hand side would have 3. This carbon here now would have how many hydrogens? 1. Because it's already making 1, 2, 3 bonds. So it only needs 1 hydrogen. This one here would make, or have?
2.
2. This one would have?
2.
2. And then the left end would have?
3.
3. And so then if we want to look at that parent chain, we have the parent chain right here with the 5 carbon atoms. Once again, we count in the direction that gives us the smallest number. So we're counting them like this. And then, again, that parent chain has 5 carbons, so we call it pentane. This branch off the parent chain is called a, what is it called again? Methyl. If you've forgotten your prefixes, go ahead and pull out your little cheat sheet there that has your prefixes on it. And so this would be methylpentane. And then, again, according to our rules, the next thing we're going to do is we're going to place the number in front of the name of the alkyl group, separating the number and the name with a hyphen. So what number should go in front of methyl? 2. And then we'd call this 2-methylpentane. Now when I write this out, there are no spaces whatsoever in this word. There's no space here or anywhere else. This is a single word with no spaces in it, and we call it 2-methylpentane. Any questions on this one? All right, next up, we'll look at this one right here. This one here now, if we count carbon atoms, consecutive carbons, what is the most consecutive carbons we have in this model here?
4.
It's 4. We actually can arrive at that a number of different ways. We can count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, and that's probably not all the ways we can come up with 4, but there are several different ways to arrive at 4 with this one here. And so what I'm going to do then is I'm going to write down that 4 carbon backbone, and then we're going to take some branches off of this parent chain so we show where those 4 are. We'll go ahead then and see how many carbon atoms on each of these branches.
1.
There's 1 carbon atom. And how many branches are there? There's 2 different branches, each with 1 carbon. This one here is attached to carbon atom number 2, and this one here is going to be attached to carbon atom number 3 in the chain. So again, if I take this off, put them off of here, we should see this one's going to go on carbon atom number 2, and this one then will go on to carbon atom number 3. Now you might say, well, why isn't it 2 and 2? Well, whenever we establish a direction, let's say if we talk about 4 people in the row here, we have 4, let's take the back row here. We have 4 people in the row. If we go down now, and we count 1, 2, 3, 4, we wouldn't want to say you're number 2 and you're also number 2. We establish a direction here. We want to go 1, 2, 3, 4 on down the row. So we do the same thing with the atoms in the molecule. Once we establish whichever direction we're going to go, we want to maintain that numbering all the way from left to right or from right to left. We can't change directions in the same molecule. So we'll show the 1 branched off of number 2, 1 branched off of number 3. Then we add in the hydrogens. The one on the top here would have 3. The one on the bottom would have 3. The right-hand side would have 3. This one here would have 1. This one here would have 1. And this one here would have 3. Now, we forgot to check on the last one, but it's always a good practice to make sure we've counted all of our hydrogens correctly. So we have 3, 4, 5. This makes 8. Plus 3 makes 11. Plus 3 more makes 14. So again, we should always check our number of hydrogens to make sure that they add up properly. Then to arrive at the name, we followed the same sequence as before. We identify and name the parent chain. So in this case here, the parent chain has how many carbon atoms? And the name of a 4-carbon alkane would be butane. Butane. And then, as we've established before, we have how many branches off of this parent chain?
2.
There's 2. Each of these branches has how many carbons? 1. So we come back here then to our rules, and on this one here, it tells us that if we have branches of, what is it? Here's multiple branches. So for multiple branches off the parent chain, we're going to count in the direction that gives us the lowest number for any branch off of the parent chain. If we have branches of the same type, so like in this case, these are both the same type, they each have 1 carbon atom. If we have branches of the same type now, what we're going to do is we'll use the Greek prefixes di, tri, tetra, etc. in front of the name of the alkyl group. So the prefix that means 2 would be di. So we would then call this one here dimethylbutane. And then we want to number those branches. So in this case here, it doesn't really matter whether we count from left to right or right to left. In each case, the lowest number would be a 2 this way, it would be a 2 going the other way. But let's say then we're going to count from left to right. This then is branched off of carbon atom number 2. This one here is off of number 3. And then according to this, says what we'll do is we're going to write the number of the position of each branch in ascending order, separating the numbers by commas. So the numbers we're going to put in would be
2 and 3.
2 and 3. And the 2 and 3 would be separated with a comma. And then the 3 and the D would be separated by a hyphen. We'll call this one here 2,3-dimethylbutane. Any questions on this one here? Okay, so now we'll look at these molecules, and what I'm going to do is I'm going to make a quick change on this one here, and I'm going to move them around like this. And we now want to compare these 2 molecules. And this is the one we did before, where the longest consecutive chain was 5. This one here as well has the longest consecutive chain of 5 carbons. But if we look at the difference between them, what is the difference between them?
3.
All right, the 2 and 3. And this one here, which is the one we looked at originally, this one here is branched off of carbon atom number 2 in the chain. And this one here is branched off of carbon atom number 3 in the chain. So because they have different branching, we then should be able to write different names for these. So now what we're trying to do is we're trying to show this one right here. So we write out the 5-carbon backbone. And once we write out that 5-carbon backbone, we see that this branch has how many carbon atoms in it? 1. And again, it's attached to carbon atom number 3 in the chain. At this point, we go ahead and add in some hydrogens. The one on the top would have 3. On the right-hand side, we'd have 3. This one here would have 2. This one here, 1. Here would have 2, and the left end would have 3. To arrive at the name, we look at the longest consecutive chain of carbon atoms, which again is 5. And so we count in the direction that gives us the lowest number for the branch. Well, this one doesn't matter whether we count 1, 2, 3 or 1, 2, 3. It's usually easiest to count from left to right then. So this one would be branched off of carbon atom number 3. What is the name of this branch called? That'd be a methyl group. And the name of the parent chain would be pentane. Be pentane because it contains 5 carbons. And the number that would go in front of the methyl would be 3. And we call this one here 3-methylpentane. If we have different names, they should wind up being different structures, and the 3-methylpentane is different than the 2-methylpentane. And if I make a slight modification to this one, something like this, now we then want to compare this structure, this one here, and now we start counting consecutive carbon atoms once again. This is the one we did before. This has the longest consecutive chain of 4. If we look at this one, this has the longest consecutive chain of
4 also.
4 as well. Now the difference in this one is if we look at that consecutive chain of 4 carbon atoms, this one here now is attached to carbon atom number 2 in the chain, and this one is attached to carbon atom number 2 in the chain as well. So each of these here are attached to the same carbon atom in that parent chain. So now, when it comes time to write out the structure, if we want to show this, again we want to show a 4-carbon backbone, 1, 2, 3, 4. We are then going to branch each of these off of the 2nd carbon atom in the chain. So why can I show them here off the 3rd carbon?
Because if you flip it around, it's on the 2nd.
Right, if we flip it around, it's going to be on the 2nd. So remember that drawing them off the 3rd one is the same as drawing them off the 2nd, because if we count 1, 2, 3, 4, from right to left, they wind up being in the same position. So then we add on hydrogens. The one on top would have 3. The one on the bottom would have 3. On the right hand side we'd have 3. This carbon would have how many hydrogens?
0.
And why would it be 0?
Because it already has 4 bonds.
Right, it's already making 4 bonds. So because it's already making 4, we don't need any hydrogens on there. This one would have 2, and the left end would have 3. Again, when we write these in, we should always confirm we have the correct number of hydrogens. So we have 3, 5, 8. 3 more makes 11, and 3 more makes 14. Then to name it, we look at the longest consecutive chain of carbon atoms, which again in this case is going to be how many? 4. 4-carbon alkane is called butane. How many carbon atoms in each of these branches? There's 1 carbon atom. A 1-carbon branch is called a methyl group. And how many methyl groups do we have?
2.
So then it would be dimethyl butane. And then we have to number the position of each of these methyl groups, and they would be both off of carbon atom number 2. And so we would write that as 2, 2 dimethylbutane. And this is different than what we had before, which was 2, 3 dimethylbutane. This one here is 2, 2 dimethylbutane. So any questions on the structures? Yes, Bree?
Why can't it just be 2? Would I have to put the 2 comma?
Because we do need to show the position of each one. So each branch off the parent chain has to have a number with it.
Okay.
Okay, anybody else?